Okay, back on the computer. Let's enable that TX station. Let's see if it finds an AP. Yes, it does. And oh, this is a little interesting. So the signal strength it's seeing from the access point is minus 77, but the access point is reporting minus 84 dBm. I would not expect that kind of 5 dB, 6 dB error in directionality, so that's a little weird. Let me just make sure these are both set for TX power 0. That one is. TX power 0, yep. So that may be a measurement error at this point. Okay, let's the interference source is off, so let's just see what they do without without any kind of interference in terms of the speed test. Now they'll negotiate up in terms of the signaling rate till they settle on something that's comfortable. Wow. Okay, so at these signal levels, we've got 63, 40% CCQs. So these modems are reluctant to go any faster than this at these marginal signal levels, which is good. That's exactly what was expected. And in terms of this report, it's seeing the station, the TX, is being seen at minus 83, which is close enough to minus 88 for this hardware. And the TX strength minus 78. So for whatever reason, the transmitter here, when set to TX power equals 0, is a little stronger than the other transmitter, or maybe just the receive is misreporting. All right, so I expect if I turn on the interference source, we're actually going to lose connectivity. So let's see what happens. What's the RX CCQ now? 42, 43% RX rate, holding steady. Wow. Okay, so we're transmitting 1 megabit, 1.5 megabit, receiving 2.8 megabit. Okay. Now remember, we're on this station here, we're receiving more from that access point. Because of the higher power level. Also, because of the way the signal is being injected. Let me get the diagram here. I don't know if this will focus. There we go. Ugh, where's my pointer? So as the access point here, which was marked RX, is transmitting data back to the station here through this attenuation chain, this interference signal source is only coupling forwards this way. It's not coupling backwards and back here. So the communication path going from the access point down to the station is actually not being interfered with, or at least not to any appreciable degree. I believe the isolation here is around 40 decibels. So the interference is only coming on the transmit direction from the from the mobile station down to the access point here. So that wouldn't account why there's a power discrepancy in terms of the readings from signal strength and TX signal strength. This has nothing to do with that, but it would support faster transmission over here because of the lack of that interference. So let me toggle the signal source here, and we'll have a look at the transmit speed of those packets and see if it slows down at all, because I did not see any CCQ degradation or any renegotiation of speeds. So let's see if the packets slow down at all. To do that, We're doing about a megabit. I think we were doing a megabit and a half or so. Yeah, there's a meg and a half. So we're jumping up and down a little bit. Still 6.5 megabit receive rate from that mobile station. And receive CCQ around the same. Yeah, let's say 1 and around 1.5. Okay, let me turn off that interference. It's off. And amazingly, that does not appear to be climbing. Huh. So this is actually really good news. The CCQs are staying the same just because of the signal levels. And they seem entirely unaffected by that interference source, even though it's blowing everything up in the spectrum analyzer mode. It's not affecting a damn thing in actual communication. Look at that. Amazing. Let me re-enable that interference. Yeah, no difference whatsoever. Let me raise the interference level by another 5 dB. Actually, I'll raise it by 6.5 dB. So that went from... Wow, that is still not... Well, wait a minute. No, this report is frozen now. There's no way that it's this steady. Oh, yep. Registration lost. Okay. Yeah, that caused the dissociation. So going from minus 41 to, let's say, minus 35 just caused the complete break of comms here. Let me drop that by 3 dB. Let's see if we get reassociated here. Not looking very good, is it? Yeah, I can't even find the network with this interference level. Let me drop another 2 dB. Hopefully it finds the network at this point. There we go. So here we're 1.5 decibels more interference power than when the bandwidth tests were running. And if we go another 2 dB more than that, everything falls apart. Let's see what we get here. Wow. Okay. It's having a little trouble keeping up with 1 megabit, it seems. Or is it? Yeah, those CCQs are 33. They used to be 42, right? So it's definitely affecting the quality of communication here. So this seems like the critical 2 decibel region that breaks stuff. You can see it's freezing here. It's not continuously updating. Of course, as I say that, it makes me a liar. But yeah, this was 42-ish, 38-ish. Now it's down to 33. Oh, and our receive rate is no longer 6.5, it's 4.8. So yeah, this is definitely being messed with because of the interference. Okay, so at this level then, minus 84, 85, If I go up 1 more decibel, everything should fall apart or come close to it. Let's see. The signal generator is injecting minus 14 dBm here. And we seem to be doing astoundingly well. Now if I go up 1 more dB, that was the level at which we couldn't associate with the access point anymore. Is it going to happen this time? 30% CCQ. Well, it's kind of holding its own, isn't it? Let's go up 1 more. Although the average rate certainly is dropping. So minus 12 dBm now for the interference source. Ah, there it goes. Okay, so 2 or 3 dB and the connection is killed. So now I wonder, with this strong interference that's preventing comms at minus 84 dBm, if I increase the power level of these modems to 1, if they'll actually associate even with that interference source being so strong. Yes, they do. Okay, that's good to know. And how do we do in terms of performance? Well, that's not bad at all. And that's at minus 82 dBm. Right, received signal minus 83, 82. TX signal is really strong. Again, surprisingly strong. I'm wondering if this received signal is reading low because of some automatic gain control amplifier in the receive path of the access point that is seeing the interference signal as well as the proper signal. It might be screwing up the level calibration. It might be reporting low. Because there's no way these two transmitters are 10 decibels off when they're both set to TX power 1. Well, that seems to be doing okay. 2.2, right? If I turn off the interference source, I wonder if that noise floor or that received signal strength will go up. Oh, look at that. Minus 72, 70. Okay, so that's much more in line with the 73 figure here. Yeah, so some kind of automatic gain control kicking in and destroying this reading. Turning off power should never make this increase.